Hi, I'm Anthony. I'm a third-year statistics PhD student at UC Berkeley, and it is my second year as an ARC scholar. I want to tell you a little bit about meta-analysis. Meta-analysis is the combination of results from different studies. Let me show you an example. So here we see results from 3 different research groups, each of which tried to estimate the rate at which the Antarctic ice sheet is losing ice. Now these groups get different results and they give different points and different error bars. And then a separate group combined these results. They performed a meta-analysis to obtain that red point with error bars. So that's a meta-analysis. But something kind of jumps out here. In the individual results, we see that the points are quite far apart relative to the size of their error bars. So clearly something is going wrong in the original researchers' uncertainty quantification or estimation of this quantity. And in a meta-analysis, this is actually something that needs to be taken into account, the fact that researchers might, for example, underestimate the size of their error bars. So given this sort of challenge, does meta-analysis actually work? And what I mean by that is, if we do a meta-analysis and we get a point with error bars, or we get a confidence interval, will that interval contain the true value as often as it should? It's a difficult question to study empirically, because to do so we would need to do meta-analyses and then see whether this interval contains the true value. But typically we do not actually know the true value in a situation when we're doing a meta-analysis. However, I constructed a dataset of old particle physics studies combined with modern, much more precise values, and this forms a dataset of studies to do a meta-analysis with and a ground truth value. Now, with these, I ran simulated meta-analyses, and I saw how often the confidence intervals from the meta-analyses contained the modern precise values. In this figure here, on the x-axis we have the number of studies we're putting into the meta-analysis, and on the y-axis we have the probability, the observed probability with which the confidence intervals contain the modern, much more precise value. This dashed line at the top is the target probability, which is about 68%, and we see that for many different meta-analysis methods, we do not achieve that probability, and especially as the number of studies gets large, we are far below that probability. And this suggests that performing a meta-analysis might lead to a rather overconfident result, an overconfident interval that is less likely to contain the true value than we think it is. So yeah, I hope you learned something, and if you are at ARC Supernova, I hope you come by my poster. Thank you.